Today we're going to learn how to find the greatest common factor when given 2 or 3 or 4 numbers. All right, so let's review what a factor is. Remember, factors are the numbers that multiply together to get that number as an answer. So numbers, okay, numbers that multiply to get that answer. For example, factors of 15 would be like 3 and 5 because 3 times 5 multiply together to get 15. Okay, today we're going to be finding the greatest common factor. We call that the GCF for short. So to find the GCF or the greatest common factor, it is exactly what it sounds like, the greatest common factor. So when you're given 2 or 3 numbers, you're going to be finding their factors and then find the biggest one that they have in common. Okay, so it's going to be like the largest factor they have in common. And today I'm going to show you 2 different ways that you can do to find the greatest common factor. The first method, or the first way that we could do that, is just by listing the factors. So we would list the factors least to greatest for each number. Okay, so if we're doing this first example, we'd have 24 and 36. The way I like to list factors is by kind of doing like a factor rainbow. What that means is like I like to list them as pairs. So like one factor pair of 24 is 1 times 24. And those ones multiply together to get 24. Then we'd have like 2 and 12. Those multiply together to get 24. I'd have 3 and 8. Those multiply together to get 24. And then I would also have 4 and 6. Okay, you don't necessarily have to draw those lines to connect them, but that's how I like to list my factors, as like factor pairs. That way I don't miss one out. Okay, and I just start counting up until we get to like a gap where there's no more numbers in between, because like 7 times 7 is not 24, so there would be no more, or sorry, right here, 5 times 5 would not be 24, so we stop there. So for 36, we'd have 1 and 36, 2 and 18, 3 and 12, 4 and 9. 5 doesn't go into 36. 6 does, and it would be 6 times 6. So we could list it once or we could list it twice. It doesn't really matter, because 6 times 6 is 36, so 6 is a factor. So it doesn't matter if it's there in once or twice. All right, so we've got to find our greatest common factor. So let's just go through. So the next thing we do is we circle the circle the factors that they have in common. Okay, so I'm going to go through. We've got 1 in common, 2 in common, 3 in common, 4, 6, looks like 12, and that's it. And remember, we are looking for the, oh, I see. I meant, sorry, to say circle the largest number that they have in common. I was like, that number right there doesn't really make sense. So we're circling the largest number they have in common. So the largest factor they have in common is 12. So our greatest common factor would be 12. Okay. If you're catching on to the hang of this, you can pause the video and work ahead on these next 2 examples and then resume the video to check. If you want to watch me do one more, you may do that as well. Now look at this. We had a 36 here and a 36 here, so I can copy that list down because we already did it. You are welcome for that. Then as we list the factors of 12, we'd have 1 and 12, 2 and 6, 3 and 4. And 3 times 4 is 12. There's no numbers in between, so we'd be done. It's okay that there's a big space there. We don't have to erase these and move them over. If you want to, you could, but you absolutely do not have to. So we'd circle all those factors that they have in common, which there are quite a lot. And we look for the largest one they have in common, which again is going to be a 12. All right, I definitely want you to pause the video if you haven't already and try this next example on your own, because then we're going to learn the second method of doing this. So this is the last example like this. All right, factors of 15. We have 1 and 15. 2 can't go into 15, but 3 can, and it would be 5. 4 can't go into 15, so we're done. 25 would be 1 and 25. 2 can't go in, 3 can't go in, 4 can't go in, 5, and it would be 5 times 5. So that was a short list. I'm going to just move that on over. We'd circle those factors that they have in common. Greatest common factor would be 5. Okay, so that's one way you can do it. Just list out all the factors and then circle the ones they have in common. However, sometimes it's really hard to do this because you miss them out. Sometimes like 36, we forget like 2 and 18. You can absolutely use multiplication charts for this, but our multiplication charts don't go up to like 18. So it's kind of tricky to list out those factors. So you might like the second method better if we don't know those factors off the top of our head. Okay, we can use a factor tree using that prime factorization. So in order to find the GCF this way, we create a factor tree of the prime factorization of each number. Okay, so if we'd have 24 and 40. Now remember, you can choose any two factors to start those off. So I'm going to choose, let's say, 6 and 4. I can break my 6 down into 2 and 3. My 4 can get broken down into 2 and 2. I'm going to write this factorization in a different color just so that it stands out. I'm just going to put it to the side here. So we'd have 2 times 2 times 2. So I'd have 3 2s and then a 3. Okay, so that's for 24. Do the same thing for my 40. I'm going to do a 4 and a 10. I'd have a 2 and a 2, a 2 and a 5. And those are all prime, so I could stop. I'm going to do this in another color as well. I'd have a 2 times a 2 times a 2 times a 5. All right, and remember we are finding the greatest common factor. So what we do now is we circle the factors that they have in common. Those prime factors that they have in common. Okay, so we have 1, 2 that's in common here, another 2 that's in common here, another 2 that's in common here, and the 3 and the 5 are not common, so we don't circle those. Okay, and then we would multiply those common factors. So here we had in common a 2, here we had in common a 2, here we have in common a 2. So 2 times 2 is 4, times 2 is 8. So their greatest common factor of 24 and 40 is 8. Okay. If you're feeling comfortable, go ahead and pause the video, try that next one on your own. If you want to see another example, you can always do the bottom one on your own as well. We've got 8 and 36. Start with those factor trees. I'm going to choose 4 and 2, 2 and 2. So we'd have 2 times 2 times 2 for 8. For 36, I'm going to break that down into 6 times 6, which would be a 3 and a 2, and a 3 and a 2. This would give me 2 times 2 times 3 times 3. And this is why I like to put at least to greatest, is because it's easier to see what's in common that way if they're not like randomly written out. Okay, so we've got this first 2 in common. We've got the second 2 in common. And then this one has a third 2, but this list doesn't have a third 2, so we can't have that in common. And then this one has 2 more 3s, but those are not in common either because this one doesn't have any 3s. So what's in common is a 2 times a 2. So our greatest common factor between 8 and 36 would be 4. Okay, if you haven't already, pause the video. You do the same exact thing for this example, except for you just have 3 numbers that you would compare. Okay, so pause the video, try this one on your own, at least get those factor trees down. And if you need help with the prime factorization or finding out what's in common, then you can resume, but at least try to get these factor trees done by yourself. All right, so I've got 10. I'm going to break that into a 5 and 2. Both those numbers are prime. So my prime factorization is 5 times 2. 20, I'm going to do, let's do 5 and 4. Then I'll break my 4 into 2 and 2. Those are all prime. So I'd have a 2 times 2 times 5. I'm already noticing I have a 2 and a 5 in common with these ones, but I'd also have to have it in common with the third one, so let's just wait. 25 would get broken down into 5 and 5. So my prime factorization would be 5 and 5. Now, when I'm doing this for 3 numbers, it needs to be common in all 3 prime factorizations. Okay, so for example, I've got a 2 here, I've got a 2 here, but I don't have a 2 here, so these 2's are not in common. Okay, so I've got a 5 here, I've got a 5 here, and I've got a 5 here. Now I don't have a second 5 in the 10 and the 20 prime factorization, so I can't use the second 5 from the 25. So my greatest common factor is just one number, it is just 5. Now, when we're doing these problems in class, or for homework or on like a quiz or test if we would have one, you can choose either method. It's not going to make you choose like the list or the prime factorization. So whichever one makes more sense to you, you can go ahead and use. But we do need to show our work for examples like this. All right.